All right, let's talk about something really cool today. We're going to dive into a super powerful architectural pattern that can help you untangle that really complex business logic, making your code a whole lot cleaner, clearer, and just way easier to maintain.
So have you ever been there? You open up a file and wow, it's just a single giant function that's a complete mess of business rules, if statements, database calls, you name it. You just keep scrolling and scrolling thinking, there has to be a better way. Well, guess what? There is. The solution is a pattern called Kernel Policy Decomposition. Now, I know that sounds a bit academic, but the idea behind it is actually super simple. It's all about creating a clear division of labor in your code. Just think of it like this. You've got a manager, we're going to call that the kernel, and their team of expert specialists, which we'll call policies. This simple metaphor is going to be our guide through this whole thing.
Okay, so here's our game plan. First, we'll talk about the problem we're actually trying to solve. Then, we'll walk step by step through how to put this pattern into practice. We'll also cover the one single rule about handling failures that, honestly, changes everything. And finally, we'll get to the good part, the huge payoff you get for thinking this way.
So, what is the big idea here? Well, it's about taking those parts of our applications where the business rules get really, really complicated. Those parts of the code base that are so gnarly nobody wants to touch them. Yeah, that's what we're tackling. We're going to turn that chaos into clean, predictable order.
All right, so step one. The very first thing we've got to do is define our boundaries. You can think of it as creating a decision family. This is basically just a container for all the logic related to one specific business job, like, say, handling a user login. This container, it could be a package or a module in your language of choice, holds everything related to one single set of rules. So going back to our login example, this would be the login access boundary. The whole idea is that if some business rule about logging in changes, you know exactly where to go. This is the one and only place you have to look. And inside this neat little boundary, we have our two main characters, the manager, which is our kernel, and the team of specialists, our policies. They work together as this self-contained unit, totally focused on getting one specific job done right. Okay, with our boundary set up, let's meet the manager. This is the kernel, and its job is basically to run the whole show. So think of the kernel as the orchestrator, right? It's the one in charge. It handles all the messy stuff, talking to databases, making API calls, and coordinates the entire process. But here's the thing, it doesn't make business decisions itself. Nope, it delegates those out to its specialists. After it gets all their feedback, its final job is to combine everything into one single coherent outcome. And this is really, really important. A kernel isn't just some simple wrapper around a single function. Its real power comes from coordinating multiple specialists. Maybe one specialist checks the user's password, and another one checks if they're being rate limited. The kernel takes all those individual decisions and combines them into a single final business result. So we've met the manager. Now let's meet the team of experts. These are the policies, and each one has a very specific, very focused job to do. And these policies, they have some pretty strict golden rules they have to live by. First, each one makes just one single business decision. That's it. Second, they have to be pure functions. That means they're completely self-contained. No database calls, no network requests, no funny business. All the data they need to make a decision has to be passed right into them. And finally, their output is dead simple, just a clear allow or deny. So this table here, it does a great job of laying it all out side by side. On the left, you've got the kernel, the manager. It runs the workflow, handles all the messy I/O and side effects. And on the right, you have the policy, the specialist. It just makes one specific decision using pure logic, zero I/O. It signals when a rule is broken, and it stays totally independent and reusable. This separation right here is the real magic of this whole pattern. Okay, let's pause here, because we're about to talk about what is, I think, the most critical rule of this entire pattern. It's a total shift in how we usually think about handling failures in our code. Just let this sink in for a second. Failure semantics belong to the kernel. What that really means is that the manager, and only the manager, gets to decide what a failure means for the entire system. So a specialist's job is super simple. Enforce the rule. Period. It doesn't try to recover from some system error, like, say, the database being down. That's not its problem. It either makes its decision based on the data it was given, or it signals that it couldn't.
The meaning of that failure? That's up to the manager to figure out. This visual makes it super clear. On the left, we see what not to do. The specialist tries to handle an error itself with a try-catch block. This is bad because it just swallows and hides the real problem. But look at the right side. The specialist simply raises an error, signaling that something is wrong. It's the manager, the kernel, that catches that signal and then decides what it means for the whole operation. Okay, quick pop quiz. Let's say a database connection fails while you're trying to fetch some user data. Whose job is it to handle that? Is it the specialist who needs the data, or is it the manager who's in charge of all the I/O? You got it. It's the manager. The kernel owns all I/O and therefore is responsible for all I/O failures. All right, so we've gone through the whole blueprint now, but this brings up the most important question of all. Why even bother with this? What's the big payoff? Oh man, the benefits are huge. Because your specialists are these pure, self-contained functions, they become ridiculously easy to test. You get this crystal clear separation of concerns. Orchestration lives here, and business logic lives over there. Debugging suddenly becomes orders of magnitude simpler. And best of all, your specialists become these small, reusable Lego blocks that you can plug in anywhere you need them. So, I'm going to leave you with this one final thought. Right now, think about the code you're working on. Where is that one tangled, complex function that everybody on the team is kind of afraid to change? That right there, that's probably the perfect place to introduce a manager and their brand new team of specialists.